When we throw a ball into the air, it follows the path of a parabola. And so in this case, here's the function that this ball we throw through the air is going to follow in this example. So I've gone ahead and already typed my equation in, so go ahead and do that. We can then use our calculator to answer a few questions about this ball. What is its maximum height? When is it at its maximum height? And then when would the ball hit the ground? So if I hit graph right now, I'm in my standard window. I can see that I don't really see a very good graph because I don't see the highest point. It's off the screen. I have all this negative time that I don't care about. So let's adjust our window really quick. My x, or my t in this case, is the input, the time. Well, time can't be negative, so I'm going to use x min of 0. And then the longest the ball is in the air, I could see that it wasn't in the air very long. In fact, I see that I already used 3. I figured that out already. I can use some common sense. Think about how long something's in the air if you throw it in the air. It's not in the air very long. The output then is the height of the ball. So once again, down here for the minimum y, the minimum output, I'm going to use 0 if the ball's on the ground. Or the highest it gets, well, I saw it was off the graph. It was a little bit higher than 10. Looks like I used 50. Again, use some common sense. If you throw something in the air, it's not going to be super, super high in the air. So I'm going to try that, 0 to 3 seconds, and then 0 to 50 feet. Now when I hit graph, I see a much better graph of that ball going up in the air and then falling back down. So the first couple questions deal with the maximum height and the time it's at its maximum height. So I'm going to need to find this maximum. We've done that a few times, so hopefully this is a quick refresher for you. But hit second trace to go into the calculate menu, and then option 4 has your maximum on there. So they're going to ask you those 3 questions. They always ask. It says left bound, which means go a little bit to the left of the vertex, so that should be fine. Then go a little bit to the right of the vertex, so I'll move over here. And that should be good. And then for guess, just guess, doesn't matter. And then right there it's telling me my x and y values for my maximum, according to the vertex. Well, let's interpret what those numbers mean. That's really what this problem's about. The time that the ball is at its maximum height refers to the x, the input value. So at about 1.25 seconds, that's when the ball will be at its highest point. The second question deals with what is the actual maximum height of the ball. That's the output, the y value. So I can see on my calculator over here that 26 feet is the maximum height of that ball. The final question then has to do with something a little bit different. They say, suppose you miss the ball, you throw it in the air and let it hit the ground. When will it hit the ground? In this case, they're asking me to find this x value out here. In other words, I want to take the equation they gave me and set it equal to 0. Well, we've done solving quadratics a few different ways. I've showed you how to do the quadratic formula, complete the square, we could try factoring. Any of those would be methods to use. I would highly recommend using the quadratic formula, especially if you have the quadratic formula in your calculator. It's a really quick way to get these 2 answers. Let me show you, though, another way to do this if you don't have the quadratic formula program. There's a few ways you can do it, but I'm going to show you this trick. Go back to y equals, and I want you to graph a second line. Graph the line y equals 0, which would just be a horizontal line that would run along the x-axis. If I hit graph, I don't know if I'll even see it. I can guess it changed color, so I can see it down there. And what I want to do now is I want to find the intersection point of the blue parabola and the red line, because that will be the time when it hit the ground. So to do that, second trace again. This time, though, select intersect, option 5. Okay, and all I really need to do is trace over so I get close to it. I don't even have to get all that close to it. Like that should probably be fine. And then just hit enter 3 times to answer their 3 questions. So first curve, second curve, and guess. And what it'll do is it'll jump to find that intersection point, and that x value will represent the time when that ball would hit the ground. The same thing you would get if you did the quadratic formula. About 2.52 seconds. If you did the quadratic formula, you would get this second answer of negative 0.025 seconds. Well, time can't be negative, so even though that would be the other x-intercept, it doesn't make sense in this problem. Time can't be negative, so I just have this one time when the ball's going to hit the ground.